In 2023, a group of astronomers reached a single conclusion. The Andromeda Galaxy is moving straight toward us. This is not a theory, not a possibility. It's a result confirmed by observation. Right now, it is about 2.54 million light-years away. But that distance is shrinking every second. Andromeda is approaching at roughly 110 kilometers per second. It still sounds far away. But think about it like this. In the last 8 hours you were asleep. It moved more than 3 million kilometers closer. Every time you sleep, it gets a little nearer. Across your entire lifetime, it has already closed the distance by hundreds of billions of kilometers. And you would never notice. But what truly surprised scientists is not just the motion itself. It's what will happen when the two galaxies finally meet. As the two galaxies begin to approach each other, the night sky will no longer look the same. Instead of familiar points of light, a massive luminous band will appear, stretching across the entire sky, brighter than any star, and so vast that you can't see where it ends. It isn't a single object. It's the combined light of hundreds of billions of stars, being stretched and rearranged by gravity. In astronomical simulations, this scene appears both breathtakingly beautiful and almost unreal. A sky that is no longer still, but in motion. And while everything above becomes brighter, somewhere else, our solar system may no longer remain where it is. Some models suggest there is a real chance we could be pulled out of our current orbit and gradually drift away from the galaxy. Not destroyed instantly, but pushed outward into intergalactic space, a place with almost no light. But to understand what's really happening, you need to look at the galaxy itself. The Andromeda Galaxy is the most distant object visible to the naked eye. Under a perfectly dark sky, it appears as a faint cloud. Soft, quiet, almost harmless. But that's only the surface. In reality, it's a massive structure, spanning over 200.000 light-years. Inside it, nearly 1 trillion stars are burning, roughly twice as many as in our Milky Way. And at its center, there is something even more significant: a supermassive black hole. Its mass is tens of millions of times that of the Sun. Compared to the one at the center of our galaxy, it is far more massive. Hidden beneath that gentle glow is a gravitational core, controlling the entire structure of the galaxy. And it is this same force that is pulling an entire galaxy toward us. But Andromeda is not a gentle galaxy. If you look closely at its outer edges, you'll notice faint streams of light stretching into space. They are not decoration. They are remnants of galaxies that once existed. In the past, Andromeda has collided with and absorbed smaller galaxies. Under its immense gravity, those structures were stretched, torn apart, and gradually dissolved within it. What remains are thin streams of stars, drifting around the galaxy, like scars left behind after a collision. One of them was once a significant galaxy in this region. But after being absorbed by Andromeda, it was reduced to a dense core, a leftover fragment of something that is now gone. And that tells us something important. The universe is not quiet. It is always moving, always colliding, and always replacing what came before. And now, our Milky Way may be next. But there's an important question. The universe is expanding. Everything should be moving apart. So why is Andromeda coming toward us? The answer lies in how the universe works. Expansion dominates only at very large scales. But in smaller systems, gravity still takes control. Just like in our solar system, planets don't drift away. They stay in orbit, not because there's no outward force, but because gravity is stronger. And in our region of space, there is a structure known as the local group. It includes the Milky Way, Andromeda, and many smaller galaxies. Within this region, gravity between galaxies overcomes cosmic expansion. So instead of moving apart, the two galaxies are slowly pulling toward each other. This was first noticed over a century ago. The light from Andromeda is shifted toward blue, which means it is moving closer to us. Not someday in the future, but right now. When the two galaxies begin to collide, things will not happen the way you imagine. There is no explosion, no direct impacts between stars, because the distances between them are far greater than you think. If the sun were reduced to the size of a coin, the nearest star would still be hundreds of kilometers away. Two galaxies can pass through each other with almost no direct collisions at all. But that doesn't mean it's safe. In fact, this is where everything begins to lose control. The gravity of both galaxies starts to pull, twist, and distort each other. The orbits of billions of stars are disrupted. Some are thrown outward, others are pulled inward. The entire structure of the galaxy begins to deform. At the same time, gas, dust, and interstellar material collide violently. Massive clouds are compressed in a very short time. And that's when a rare phenomenon occurs: a burst of star formation. Millions, even billions of new stars ignite almost at once. Their light makes the galaxy shine brighter than ever before. But with it comes something far more dangerous. The number of supernovae skyrockets. Massive energy explosions happen continuously across space, and among them, some release intense gamma radiation, a type of radiation capable of wiping out life across vast distances. No direct impact needed, just being close enough is already the end. But for our solar system, the most likely outcome is not destruction, it's ejection. As the two galaxies move closer, their central black holes begin to interact. Extreme gravity creates a slingshot effect. It can accelerate star systems and throw them out of their paths. If that happens, our solar system could be pushed to the outer edge of the galaxy, or even completely ejected into a place with no light, no stars, only darkness. Earth would not explode. It would still exist, but it would become an isolated world. As the sun slowly fades, oceans freeze, the atmosphere disappears. Life does not end instantly. It fades in silence. But there is something unexpected. This scenario may not be certain. New models suggest the two galaxies might not collide directly. In some cases, they may simply pass by each other, which means this future is not fully written. But no matter the outcome, one thing remains true: Andromeda is still moving closer. Right now, with every second, with every night you sleep. And it reminds us of one thing: Earth is not the final destination. It is only a temporary place in a universe that never stands still.